Hello everyone. In this lecture we will discuss an example of finding the approximate value of the derivative of a function at a point by using the 3-point formulas. In the last lecture we discussed 3-point formulas for approximating the derivative of a function at a point. Now let's discuss an example. The values of f of x equal to x e power x are given in this table. That is, we are given the x values 1.8, 1.9, 2, 2.1 and 2.2, and the f values, that is the function is here f of x equal to x into e power x, and the values at these points are given by this. Use all the applicable 3-point formulas to approximate f dash of 2.0. That is, we need to find an approximate value of f dash of 2 by using 3-point formulas. We already discussed two types of 3-point formulas. First one is 3-point endpoint formula and the other is 3-point midpoint formula. So here we are given the values, x values are 1.8, 1.9, 2, 2.1 and 2.2. Here we need to approximate the value of f dash at this point 2, right? So here we can use four different 3-point approximations. First one is we can use the endpoint formula with h is equal to 0.1 or h is equal to minus 0.1, because we have to find the derivative or the approximate value of the derivative at this point too. So to use the endpoint formula, this value will be at the endpoint. So if you are using h is equal to 0.1, so we can use these points to find the approximate value at this point too. We can use if you are taking h is equal to 0.1, we can use these points 2, 2.1 and 2.2. So we can, in that case, we can take this as x naught, this as x naught plus h when h is equal to 0.1, and this is x naught plus 2h. So by using h is equal to 0.1, we can use this endpoint formula with these numbers. Also, we can use these three numbers to find the approximate value at the point 2 using endpoint formula. So in that case, we can take this as x naught and this value as x naught minus h, and this as x naught minus this is minus 2h. Or we can take this as if you are using here h is equal to minus 0.1, then will we have x naught equal to x naught minus h is, or x naught plus h is equal to 2 minus 0.1, so 1.9, and x naught plus 2h is equal to 1.8, etc. So we can use 1.8, 1.9 and 2 to find the approximate value of the f dash at the point 2 by using the endpoint formula. So we can use the endpoint formula with h is equal to 0.1 and which h is equal to minus 0.1. Also we can use the midpoint formula. We know in midpoint formula we will use to approximate at the point x naught, we have to use x naught plus h and x naught minus h. So if we can use these three numbers, that is we can use this 1.9 and 2.1. If you are using this as x naught, then this will be x minus h and this will be x plus h. Okay, if you are choosing h is equal to 0.1. Now if you are choosing h is equal to 0.2, we can use the numbers as x naught equal to this, x naught plus h is equal to this, because we are using h is equal to 0.2, and x naught minus h is equal to equal to 1.8. Okay, so in that case also, to use the midpoint formula, we can use h is equal to 0.1 or h is equal to 0.2. So we can find four different approximations by using 3-point formulas. Okay, so first we can approximate the value of f dash of 2.0 using the endpoint formula with h is equal to 0.1. We know the endpoint formula is given by f dash of x naught is equal to it is approximately equal to 1 by 2h into minus 3 into f of x naught plus 4 into f of x naught plus h minus f of x naught plus 2h. Okay, so we have to approximate the value at the point 2, so we need to take x0 is equal to 2. So here if you are choosing h is equal to 0.1, we have f dash at the point 2 is approximately equal to 1 by 2 into h, that is 1 by 0.2, because h is equal to 0.1, into minus 3 into f of 2 plus 4 into f of 2 plus 0.1, because h is equal to 0.1. So f of 2 plus 2.1 minus f of x0 plus 2h is f of 2.2. Now we can just replace the value of these f values, that is f of 2 is actually given from the table is as this 14.778112. F of 2.1 is this 17.148957, and f of 2.2 is this value. Okay, so simplifying that, we will get the approximate value of f dash of 2 is nothing but 22.032310 by using the endpoint formula with h is equal to 0.1. Okay, now using the endpoint formula with h is equal to minus 0.1, we have this. We can use the same formula, but we are taking h as minus 0.1. So this formula will be implies, that is f dash of 2 is approximately equal to 1 by 2 into h, that is 1 by minus 0.2 into minus 3 into f of 2. F of 2, I mean f of x0 is f of 2 plus 4 into f of x0 plus h, that is x0 minus 0.1, x0 equal to 2, so 2 minus 0.1 is f of 1.9, and minus f of x0 plus 2h, that is f of 2 minus 2 into 0.1 means that is minus 2, so f of 1.8. Now using the values of f of 2, f of 1.9 and f of 1.8 from this table, we get the required approximate value of f dash at the point 2. Okay, that is we can replace these values here, and simplifying this, we'll get the approximate value of f dash of 2 is nothing but 22.054525 if you are choosing h is equal to minus 0.1 with endpoint formula. Okay, 3-point endpoint formula. Now we can use the 3-point midpoint formula with h is equal to 0.1 and h is equal to 0.2. Now we know the midpoint formula is given by f dash of x naught is approximately equal to 1 by 2h into f of x naught plus h minus f of x naught minus h. If we are choosing x naught equal to 2 and h is equal to 0.1, we have f dash of 2 is approximately equal to 1 by 2 0.2 into f of x naught plus h is 2.1, so f of 2.1 minus f of x naught minus h, that is f of 1.9. So replacing these values of f of 2.1 and f of 1.9 from the table, we get this. So simplifying, we'll get 22.228790. Now with h is equal to 0.2 and x naught equal to 2 in midpoint formula, we get f dash of 2 is approximately equal to 1 by 2 into 0.2, that is 1 by 0.4 into f of x naught plus h, that is 2.2 plus 0.2, that is f of 2.2 minus f of x naught minus h, that is f of 1.8. So replacing the values of f of 2.2 and f of 1.8, we will get 22.414163 as the approximate value of f dash of 2. So we obtained the approximate value of the derivative of f at the point 2 by using the endpoint formula with h is equal to 0.1. We get the answer as 22.032310, and with the endpoint formula with h is equal to minus 0.1, we obtained that f dash of 2 is approximately equal to this number 22.054525, and using the midpoint formula with h is equal to 0.1, we obtained that f dash of 2 is approximately equal to 22.228790, and using midpoint formula with h is equal to 0.2, we have obtained the f dash of 2 is approximately equal to 22.414163. Now if you are trying to find the actual value of f dash of 2, we know our function is f of x equal to x into e power x. Therefore f dash of x is equal to e power x into x plus 1. Therefore f dash of 2 is nothing but 2 plus 1 into e power 2, which is equal to 22.167168. This is the actual value of the f dash of 2. So the approximation errors of the above formulas will be as follows. That is, for 3-point formula, 3-point endpoint formula with h is equal to 0.1, we have the approximation error is 1.35 into 10 raised to minus 1. That is 0.135. This will be the approximation error. That is this 22.167168 minus the approximated value is this. Okay, first one 22.032310. So we will obtain the approximation error as this. And in the second case, by 3-point endpoint formula with h is equal to minus 0.1, we obtained the value. So the error will be this value minus that approximated value. So we will get 1.13 into 10 raised to minus 1. That means 0.113. This will be the approximated the error. And from the 3-point midpoint formula with h is equal to 1, the error will be this minus 6.16 into 10 raised to minus 2. So the error is decreases by using this midpoint formula. And by using midpoint formula with h is equal to 0.2, we have the error will be minus 2.47 into 10 raised to minus 1.